Welcome to Georgia Highlands College Math 97 and Math 99 video tutorials. In this video segment, we'll be answering the question, how do you solve rational equations? Well, the first step in this process goes back to an old video, and that's you've got to list the restrictions on what you can plug into the equation. So you need to go through and find out what will make any of the denominators zero, because we know we don't want zero in a denominator because dividing by zero is undefined. So we want to identify those values that would make the denominator zero first, because if they show up as solutions, we want to discount them. Secondly, you're going to clear fractions out of the equation. And you're going to do that by multiplying every term in the equation by the LCD, or least common denominator. Then you'll solve the resulting equation. Now that may look different for different types of rational equations. You might end up with a linear equation or a quadratic equation. So you have to know how to solve all the types of equations that we've talked about in previous chapters. And then finally, you'll either reject any of the solutions that show up that aren't really solutions because of the restrictions placed on the input variable, or you're going to check and accept the other solutions that you're left with. So let's take a look at an example. All right, so we have a rational equation here, 5 over 2x equals 17 over 18 minus 3 over x. And the first thing that we need to do is figure out what we absolutely cannot plug in for 0. So if you look over to the side here, I have the situation set up where I've taken each of my denominators and said these cannot equal 0. So if I solve these equations here, I'll find out what x cannot be. So to isolate x in this first, I divide by 2, and 0 divided by anything is just 0. So in that case, we have the restriction that x cannot be 0. So if we run through all of our steps to solve this equation and we get 0 out, we simply cross that out because it cannot be 0, because it will give us a 0 in the denominator if we plug it in. Well, our second denominator, 18, that's not 0, and it never will be 0. So we don't really have to worry about that denominator when it comes to restrictions. And then this last one, 3x, well, if we divide by 3, we also get here that x cannot be equal to 0. So the same restriction shows up with that denominator as well. All right, so now that we've identified what x cannot be, let's go back and see if we can figure out what x actually is. So the first step in this process is to clear fractions, and we do that by multiplying every term. So we've got 3 terms here in this equation, 1, 2, 3. We're going to multiply every term by the LCD. Well, I've set off a little area to the bottom right to figure out what the LCD is. So I just want to do the prime factorization for each of my denominators, 2 times x. 18 is 6 times 3, which is 2 times 3 times 3. And then 3x is 3 times x. So my LCD, remember how we find the LCD? I list out the first factors of that first expression there. And then I move to the second expression and add any factors that haven't shown up yet. So I actually have 2 3's in that second one. Since I already have a 2, I don't need to add it again. And then I look down at 3x, and I've already got a 3 and I've already got an x, so I've got my LCD there, which is 2 times x times 3, or 18x. But I'm actually going to leave it factored, and you'll see why here in a minute. I find it to be a little bit easier when it's in factored form. All right, so the next step I'm going to do is just rewrite my problem, and I'm actually going to go ahead and factor all of the denominators within the problem. So I have 5 over 2 times x, and that equals, I'm going to leave myself space, and you'll see here in a minute why I'm leaving this space. 17 over, okay, so 18 is 2 times 3 times 3, minus 1 over 3 times x. Now I'm ready to multiply every term by the LCD. So I come back and multiply each of these by a 2, an x, a 3, and a 3. Now this is completely legal because this is an equation. And as long as you do the same thing to both sides of the equation, it remains an equation. All right, so I've multiplied each of my terms by the LCD. Now here's the reason that we did this. We want to get rid of these denominators. So look, anything, and by the way, these are all living in the numerator. So let me just extend my fraction bar there to show you that all of those factors are living in the numerator right now, which allows us to come back and say anything divided by itself is 1. Anything divided by itself is 1. This is exactly why we had to hit up every factor that showed up in the denominator, because we wanted to be able to cross out all of our denominators. And now I'm just going to rewrite what we're left over with. So I have 3 times 3 times 5, and that's all over 1 now, so I don't have a denominator left except for 1, which you know is understood to be there. And then I've got x times 17, and I'm subtracting 1 times 2 times 3. So no more fractions to worry about. Now I just need to keep on with the simplification process. 3 times 3 times 5 is 9 times 5, which is 45. 17 times x is just 17x. And 1 times 2 times 3 is 6. And we're subtracting that 6 off. So I have a nice, neat, linear equation to solve. So I begin unpacking everything that's hanging on to that x to isolate the variable. So first I'm going to add 6 to both sides to get that negative 6 away from the variable. And this is 51 equals 17x. And now I divide both sides by 17. And I am left with x is 3. So whenever you get to the bottom and you have your potential solutions, and I'm calling it potential on purpose, the first thing that you need to do is check the solution you found against your restrictions. So the only restriction that I have is 0 for this particular problem. So right now 3 is legal. We just need to make sure that it's actually the solution and makes our original statement true. So I'm going to check it to make sure. All right, and you always check in the original equation. So 2 times 3 equals 17 over 18 minus 1 over 3 times 3. All right, so just continuing to simplify, I have 5 over 6. Let me just remind you at this point, whenever you're checking an equation, you simplify down either side of the equation. You don't move things from side to side when you're checking. You just simplify down each side and see if you equal out to the same thing on both sides. That's the true statement we're looking for. So 17 over 18 minus 1 over 9. Okay, I need to get a common denominator on the right-hand side, so I multiply by a clever form of 1, 2 over 2. And I have 5/6 equals 17/18 minus 2/18. Oops, I'm running out of room. Let me come this way. Sorry about that. So I have 5/6 equals, well, 17 minus 2 is 15/18. And when I simplify 15/18, 3 goes into 15 5 times and into 18 6 times. So I get 5/6 there. So 3 is our solution to the equation. We've checked it. We made sure that it wasn't a restricted value. So we're safe to say that 3 is the solution. I hope that this has been helpful for you in beginning to understand how to solve these rational equations. The big idea here is to not even deal with the fractions. Just clear them out by multiplying every term by the LCD. Now, we'll have a couple more videos in this series solving more complex rational equations each time, just so that you can get a good feel for how to go about solving these. If you have any other questions, please contact your Highlands instructor. Thank you.